Hi, welcome back to the breadboard. Today we're going to talk about motion control, specifically for CNCs. I have a number of devices either already built that we're going to go and have a look at, or that I am about to build over the coming few videos. And what I wanted to do first was to go over the basics of motion control with various controllers, various drivers, what kind of software you use to design models that you're going to use for the motion control, and more importantly to show you a lot of the commonalities between different CNC type machines. What's behind me here right now is my 4x4 foot cutting area CNC that I had shown you being built on a number of earlier videos, and I'll provide the links in the description so that you can go have a look at those if you want. What I've been doing since then is I've built a smaller CNC that is only about 500 millimeters by 500 millimeters, so a little over 2 feet or about 2 feet by 2 feet cutting area, which has got a lot more precision and a lot more robustness to it. And I've also now got a CNC cutter, laser cutter, which is in the garage with me over there, which I'll show you in just a moment. But I'm also going to be building a pair of 3D printers, and I'm also going to have a look at one 3D printer that I already have as well. The reason I want to look at all these different things is because they all have a lot of parts that are absolutely in common to each other. They may vary in scale, but they perform the basic and pretty much the same function. So a couple of other things that I've done since the last video talking about the CNC is I've actually added right here the Phatek 12-inch touch LCD display, which I had featured in a previous review. This is now wired into the CNC, and as you can see, fully supports touchscreen and everything else. What we also have connected to this display is an industrial PC that was featured in a previous video from Perfectron, and that is the unit that's now mounted to the back wall. It has no fans, it runs on 24 volts DC, not mains, and together these things will allow me to control the laser cutter, the CNC, and also the smaller CNC if I bring it out here for doing anything that's really messy for cutting. If I'm doing simple laser cutting maybe indoors, then I could keep it there, but for everything that comes out here, it's going to go through that PC there. So let's have a little bit of a closer look at a couple of things here. Now this CNC is partly in pieces at the moment because I stole a few of the parts to use to build my other smaller CNC, and I'm going to use the smaller CNC to cut out of some aluminum plate a new X gantry rail system so that it's going to be more robust here too. I have a C-section, the same as I put on the Y gantry, to go across here, but I don't have the X plates yet that are going to work with that with belt driven. So that's going to be a feature of another video as well. So anyway, let me just take the camera off the tripod and we will have a closer look at the various things, including the laser cutter, and then we'll head back indoors to look at the 3D printer and the smaller CNC, and you'll see all the commonality. Okay, so what we have here is a view of the end of the gantry. So it's running from this position 5 feet across to this side. What you can see still are the two stepper motors still mounted with the belt pulleys there, and the X stepper motor and the Z stepper motors are basically both sitting on the bench here because I've taken those rails off for now, along with the actual router and an e-stop that's waiting to be fitted. Now on the back wall, if we come back up here, you'll remember we went through the power supply up there, which is a 48 volt 10 amp power supply, and the smaller one to the left is a 24 volt 5 amp supply. Below that, after the power distribution, we have a number of Gecko Drives. I showed you how to wire some of those up in one of the videos, and I will be going through that again in more detail. We have 4 of them right now, 2 for the y-axis, 1 for the x, and 1 for the z. To the right of that, just here, is a home-built Arduino Uno based G-code interpreter, which is talking to the stepper motors to control the motors themselves. So these steppers all work on the 48 volts 10 amp power supply to drive the actual stepper motors directly. The Arduino Uno there can either work off of the USB power, or I've just got a little DC to DC converter there to tap off of the 24 volts. Now my intention is that this PC that is now screwed to the wall will also tap into the 24 volt power supply, but I've got to think a little bit about how I want to wire that, because I don't always want to power up the CNC power electronics just because I want to have that PC on. So I think I'll be doing a little bit of rewiring of the mains up there to accommodate that. I have another panel that I'm thinking about mounting in this area, perhaps for the other CNC or for some other variation. We'll cover that in future videos. So let's just back out a little bit here, and here we have, just trying to move to a better position. So this is the Phatek 12-inch display, which is all nicely tapped in and working on touch control, and that is mounted to the side of the table. Anyway, let's go and turn around now in here, and we'll look at this side where we have the new laser cutter that we now have up and running. Now I have been preparing a video to go through a lot of the safety issues that had to be dealt with when we got this laser cutter. It's a Chinese import. There's nothing particularly wrong in that, but you have to set certain expectations when you get a laser cutter, especially if you bring it in from overseas, that it may not fully meet all of the local regulations as far as grounding, the types of sockets and things like that. A couple of things that are outside of the laser cutter is down there is a little air pump to provide a small amount of airflow to the nozzle of the laser to keep debris away from the final focusing lens. Here is the main control power for the thing, and you can see there's absolutely no markings to tell you what is what. I added the Ethernet connector at the bottom. The next connection up right there is actually the PC USB in, and as you can see, it's using really the wrong connector. That should be a USB type B connection. That's really for a host out. On the top of the laser we have the same controls. You've got a switch control, we have elevation for the platform up and down, we have an exhaust fan to turn the vacuum on and off to suck all the fumes out of the laser cutter, and then we have a switch for a light. We have an e-stop, which actually at the moment does not stop any of the motion control. All it actually does is kill the actual laser itself. We have 2 gauges here for water temperature and ambient temperature. Now what I wanted to show you for now, I'm not going to go into any more detail about the basic using of the laser, but I wanted to show you on the control here we've got XY movement controls for the laser head, and this also supports on the controller a Z control too if you ever fitted it, and even a U axis if you wanted a rotary axis as well. Now remember those things, because when we go back through you'll see a lot of commonality. So here's the inside of the laser, and we have pretty much the same kind of thing. We have a Y gantry consisting of 2 rails, one on the left here and one on the right. And so the laser head, this is the actual final head focusing down onto the job, can move forward and backward under stepper control. The X-axis can move, this is completely powered off right now, left and right on the rail here, and that is powered by a single stepper motor which is mounted down here. We've got end stop sensors, mirrors for reflecting the beam, of course, from the CO2 laser which is in the back here, through the hole here up to this mirror, up to the final mirror, down onto the work surface. There is a motor control to raise and lower this bed as well. That's not hooked into any automation. You just push a button to go up, push a button to go down. The main point here is that we have an X-axis a y axis, so here's the x, here's the y, and then the z basically is just manually adjusted right now. This is all under computer control. It doesn't take G-code the way that the CNC does, but it does take basically coordinate files as well anyway, and then controls the laser from that. Now if I just open up the side panel a second, I'll show you the controller. So here's the actual controller. There's a HMI display which is on the top, which we were looking at just a moment ago. And as you can see on the bottom right of it, right over here, we actually have 4 axes control capability. So there is the X, we've got the Y, we've got a Z. Just try and focus that a little better. And then we have the U axis, and all of these could additionally be wired in with steppers. What we have special for this is a 2 outputs on the top, this one and this one, for controlling the lasers, and then on the left side of the controller we have inputs for limit switches and things like that, and power of course. So what this has in common with a CNC machine, but let's go back now and look at the CNC router, and we'll see what the common components are to that. So on the large one we've got the y-axis, which is this and rail and this one, and again we have 2 stepper motors in this case because it's such a large gantry. On the laser there was only 1 stepper motor, but there was a shaft that ran between the left and right side to keep both sides being driven equally. Now what's not on here right now, which we'll see when we look at the smaller one, is the X gantry that would normally run left to right, and then the Z gantry which would run up and down. As I mentioned with the laser, the Z is done manually at the moment, but it could equally be easily automated by adding a stepper motor instead of the DC motor that's in there. The controller that we have over the back here, we looked at the one on the laser that had X, Y, Z, U, all the sensing inputs for limit switches and things. That in this case is done by this Arduino Uno, and I've put some opto-isolation circuitry and things like that on that little daughter board that you can see, just to provide some protection. The drivers are these 4 Gecko drives. Now on the laser, the drivers are, let me just go back over to the laser. I didn't show you those. The drivers are sitting there. There's only 2 of them, and that's these units at the bottom. There's one here and one here that actually drive the stepper motors. So you can see there's a lot of common components between this. So we've got all these separate stepper drivers and everything else too. The laser is probably working off of 12 volts, not 48 volts for the stepper drivers. But aside from that, it's only a matter of scale. You can see this is much, much bigger. Normally you have, I think I weighed the whole gantry here and everything with the router and that, and I think it was about 11 or 12 kilograms that was being moved. And as you can see with the laser down here, all you're moving is this small piece of aluminum, so it is very, very much lighter, which is why it can get away with using just NEMA 17 stepper motors. And you can see here actually that this stepper motor here, this is the one that's driving the y-axis, and there's this shaft that runs right up the other side, so there's a belt over here and a belt over here that's keeping it all coordinated together to move the y-axis. On the z-axis there's a belt that runs through from that stepper motor, and it's just this on the single rail. So that's the laser and the large CNC router. Now let's go indoors and let's have a look at the smaller CNC and the 3D printer to see if we can identify the various components for that as well. Here we are in the basement now, and we're looking at the smaller CNC, and what you can see here is a lot of very similar infrastructure. For instance, there's the Y gantry here and here, and there's a stepper motor on the end of each one, right there and right there. We have the X gantry running across, and there's a stepper motor actually right behind here, underneath here. So there's a stepper motor there to drive that, and then we have the Z axis right here driving a Acme rod in this case to drive this axis up and down. We have a bracket here for mounting the router itself onto the unit. But aside from that and scale, the motion, and these are also NEMA 23 motors, the same as on the larger one. The difference being that these are 0.9 degrees per step instead of 1.8 degrees per step, so 400 steps per revolution. But what differs here is actually the controllers that I'm using. So these are slight, because this is a smaller and lighter unit, I don't need as much power on the stepper motor. So even though these are much more accurate steppers, they're actually a slightly lower torque rating than the ones on the large CNC. And as such, I was able to go down to a smaller driver. This is actually upside down right now. Let me see if I can turn it around. So what we have here is a Gecko Drive G540 controller that is containing 4 stepper motor drivers built into this, and it uses a standard parallel printer kind of port interface. Now this is a very common interface for a lot of motion control systems, especially in the home and small industry market, because you just take the parallel port on the output of a PC and you just feed it straight to that connector, and you're able to then send commands to the drivers to move the head around and do your cutting and everything else. Now the only issue with that, of course, is that modern PCs don't have parallel ports. So what do you do? And also, if you wanted to offload some of the control to something else, what do you do? Well, in this case, what I have is a Mach III motion control card. Now this was supplied to me by SNB-Solutions out of Barrie, Ontario, for reviewing and using with my project. I'll provide a link to his site in the write-up. So for control perspective though, I had to build a little adapter board here, and the reason for that is because this Mach III motion control card has a 5-volt output, which is usually used to drive into the LEDs of the stepper driver, and then the return path would go, so you can see here, if I can get it to focus, back off a little bit, there we go. So you've got direction and pulse, so step. It would normally ground that end and thereby illuminate the LED on the driver card inside on the opto-isolator to drive then the stepper motors. Now because the Gecko Drive actually relies on feeding a voltage into the controller, and I'll show you this in a schematic in a minute, I had to basically build a little interface board here. Now all this does is just take some half K pull-up resistors, about 500 or 480 ohms or something like that, from the 5 volts here, and just pulls the inputs up. So as long as this isn't driving it to ground, this will be fully at 5 volts, and that will be enough to drive the LEDs. Of course you need to set up Mach 3 or whatever your control software is to understand that appropriately. This controller too is got all of the limit switches coming into it, and I have a temporary e-stop wired here as well, which just goes into one of these pins, into the Gecko Drive. Now when you're wiring up a motion control system, the important thing about safety is you want to kill the power to the drivers, not necessarily to the controller, because if this is working under software control and the software crashes, you hit that limit switch, it might just ignore it. If you feed it into the enable of the motion control drivers and you hit that limit switch, then you're going to kill the power to the steppers themselves, and all motion will immediately stop. Now this whole system, because of the nature of these this unit here, is only rated up to 36 volts, and also the Gecko Drive does not go up to the same voltage as the drivers that I had outside. I can't remember exactly what it is. This whole thing is running from a 24 volt 10 amp supply instead. So all of this is basically then fed from a PC. You can use Mach 3 in either situation, or one of the other many available G-code interpreter kind of control pieces of software. Now this one here is specifically designed to work with Mach 3, which is why it's called a Mach 3 motion card. The Arduino Uno version outside it will work with the things like the universal G-code sender and stuff like that. So as you can see here, compared to the laser cutter, we've got an X, Y, and Z. We have a controller which interprets the code, drives stepper drivers. In this case it's a 4 stepper drivers built into one unit. In the large CNC it was 4 individual stepper drivers. In the laser there were 2 stepper drivers because we're only driving the X and the Y. And one of the things that I haven't mentioned for all of these is that they have a sense of spindle power. So on a rotary spindle, like a router, you would change the speed from say 1000 RPM to 10, 15, 20, even 30,000 RPMs depending on what you're cutting and how fast you want to cut. On a laser you would still have an effective cutting speed, but instead of changing the rotational speed of a cutter, you're changing the amount of intensity of the laser light to cut through your acrylic or your plywood or whatever it is you happen to be cutting. But the basic controls, whether it be 0 to 10 volts or pulse width modulation or something like that, is the same for all of them. It's just cutting speed. So you've got your feeds, which is how fast you're moving around the table, and that's the same for the laser, the CNC large CNC router or the small CNC router. And then you've got your speed of your cutting, which in the case of a rotary axis will be translated into RPM, and in the case of the laser cutter it will be translated into intensity of the beam. Now the last thing I want to have a quick look at is a 3D printer, so let's just go over and have a look at that. Okay, so here is my CEL Robox 3D printer. Sorry about the slightly dim lighting for this. I'm just hand holding the camera, and it's not in a well lit room right now, and I've got it ready to start doing some printing. But basically what we have here is we have a bed here. So we've had the same thing on the 3D printer and the laser. In this case the bed is able to move. And this is the Y-axis, so instead of the head moving in the Y, the bed will move in the Y. We have the head, which can move in the X-axis, and the head via a stepper motor over here, and linked to a pulley on this side too, so there's threads on either side, can actually drive the Z-axis up and down. So you've got the same 3 directions of control as you had with the laser cutter and as you had with the 2 CNC machines. Now in this case we don't have a laser beam, we don't have a cutting head. What we do have is an extruder, and for that we have a 4th stepper motor. I've taken the side off so you can see, which is here, which actually drives a tooth cog and forces filament from here through a Bowden tube up to the hot end, through the back and to this hot end, where it is melted and then deposited on the printer bed. And that is the equivalent to the speed. So the feeds is how fast we move in the X, Y, and Z directions, and then the speed is, in this case, how quickly we extrude plastic through the hot end and onto our build plate. But aside from that, and again these are using, it looks like about NEMA 11s size stepper motors, it's exactly the same again, except the fact that we have a smaller scale of everything. So we have NEMA 11s, NEMA 17s on the laser cutter, NEMA 23s on the 2 CNC machines. So we have Z-axis stepper here, and I believe there's one underneath there as well to drive the Z-axis up and down. We have a motor here for the X-axis. We have a motor, where is it? Down here for the Y-axis, and there's a motor buried in here for the feed rate out to the hot end for the filament. And the controllers in this case are all built onto this board that I can't really get a good shot at, but it's all built onto the motherboard. They're much smaller controllers because these only take maybe an amp each when they're stepping versus 3-4 amps for the bigger NEMA 23s on the big CNC machines. The laser with the NEMA 17s in it, they probably draw maybe a couple of amps or something like that at best. So it's the same motion control, it's just scaled to a different level. I'd like to thank RS Components for providing all of the electronics, or most of it, stepper motors, driver cards, power supplies, etc., and a lot of the wiring capabilities. Also SNB-Solutions for providing the extrusions and the Mark III motion control card. A lot of the future videos that are going to be coming out are also going to be sponsored by SNB and RS Components and others, so I will let you know and have links to all of the components that I use as we go through. Future videos will be discussing any key elements, for instance limit switches, homing switches, safety aspects, wiring, etc. So I hope to see you there. Thanks a lot. Bye.